count the number of beautiful subarrays. So for this problem, we are giving a zero-indexed integer array nums. So in one operation, we can choose two different indices I and j such that I and j gonna more than equal to 0, less than the length of the nums. And we can choose a non-negative integer k such that the k's bait it is a zero indexed, in the binary representation of nums I and nums j is 1. So what does that mean? It is so long. So the description is so confusing. Let's just try to understand what is the meaning. We can choose a non-negative integer k. So what is this k? So for example, this gonna be a binary bit 111011. So this is a binary number. And we can choose a non-negative integer k, zero indexed. Maybe k is here, 0, 1, 2, 3. Maybe k equal to 3. K equal to 3. K gonna be here. So we're gonna count k from the right to the left. So this is the low bit. So if k equal to 3, it's gonna be this bit. Such that the k's bit in the binary representation of nums I and nums j is 1. So if this is 1, we can find this k, and the binary bit is 1. And then we're gonna subtract 2 to the power of k from the nums I and nums j. What does that mean? Normally this means we can minus 2 to the power of 3 if k equal to 3. We can set this bit from 1 to 0. So this is just the meaning. So for another binary number, so for example it is 100, maybe 1000, and this is k equal to 3 for this bit. We can set this bit to 0 as well. So for each of the operations, we can set 2 bit of the binary number to 0. So what does that mean? Actually, this is just the XOR operation. So the XOR operation, if this bit is 1, this bit is 1, so finally it's going to be 0. So this is what we are doing. It is just actually the XOR operation. So this means for any bit, so for the first for a number, if it is 1 1, and for another number if it is 1 1. So if the number of one bit in this position is even, and the number of one bit in this position is even, so definitely we can set this number to be 0, and this bit to 0 and this bit to 0 as well. Because finally we just need to return the number of beautiful subarrays. So what is beautiful subarrays is 0. If we can do such kind of operations and we can make the subarrays to 0, so this means it's going to be beautiful array. And as I explained earlier, this is going to be the XOR operation. By using the XOR operation, if the one bit is even, definitely we can make it 0. So if it is still 0 0, it doesn't matter. So if it is like 1 0, we cannot make it to be 0, right? Because 1 XOR 0 is going to still be 1. So this means we can use the XOR operation. If it is 0 0, it's okay. If it is 1 1, it is still okay, because by using the XOR operation, it's going to be 0. But if it is 1 0 or 0 1, it is not okay actually. We just need to check all such kind of cases. Now we have such kind of array. So maybe for the numbers, it's going to be A B C D, E for such kind of numbers inside the array. We just need to check if A XOR B equal to 0, so this is a valid subset. If A, B, C, by using the XOR operation equal to 0, this is also a valid count. But in this way, it's going to be O(n) squared times complexity. Definitely it didn't work because n going to be 10 to the power of 5. So this means we're going to use maybe the two-sum idea, or we're going to use a hash table to find it. So for example, if we find 1 1, so 1 XOR 1, it's going to be on 0, right? This means we've already found a valid case. Maybe from here it is not 1 1, we didn't find it, but from here we found another one, and here another one. So this means from here we found another 0. But how many cases? Because this 1 1 is a valid case, because 1 XOR 1 is 0. But the whole array is also a valid count. So how many count? So from here, this is one count. From here, this is 1 plus 1. It's going to be 2 count. Maybe in between we didn't find XOR to be 0, but here we find another 1, 1. So this one going to be 3. Yeah, so this means the total count is going to be 1 plus 2 plus 3. So it is not only 0. Maybe from some other places, by XOR operation like 1, 2. I don't know. What is 1, 2? So 1, 2 is 0. Let's use another case. Maybe 1, 3. Yeah, so for 1, 3, it is 0, 1, and 1, 1 by using the XOR operation. It's going to be 2. Yeah. Maybe from other places we find another 1, 3. So the XOR operation going to be 2. Or maybe from other places we find a number 2. Yeah, 2 with the XOR. Yeah, but something in between we don't know. But by using the actually this is a prefix sum. By using the prefix sum while it goes to here, we find another 2. And this is a prefix sum from here. This means by using the prefix sum, this means if this is a 2, this is a 2, we find a valid subarray. This means, yeah, the number. Yeah, so if this is a 2 and this is a 2, this means we find another valid case. Because this number 2 XOR this number is going to be 0. So by using the XOR number, it's going to be the next number after this 3 to this number 2. In between here, the XOR operation is going to be 0. Yeah. Now let's just start coding. Actually, the coding is going to be much easier. So we're going to use a counter, and inside the counter we're going to set 0 to be 1. Yeah, this is just the edge cases for us to check the counter. So this means if we find a 0, we're going to count it as 1. So for example, if we find a 1 and a 2, 1 and 2 going to become 0. So we find a valid case. So we're going to count it as 1, and then we're going to update the counter. Yeah. So the result is going to be 0. Let's just check the numbers one by one. Yeah, let me prepare a total variable as well, because we need it later. Yeah, so for any number inside of the nums, we're going to use the prefix sum, so it's going to be total, or maybe let's just use the maybe. Yeah, the prefix sum. XOR with this number n. Yeah, and then we're going to update the result, going to plus equal to d with this prefix. Yeah, it's this number, d prefix of this number. Yeah, if this number is, for example, is 1, so the result is gonna update it to 1. This means we find a valid case. So after that, d prefix gonna plus equal to 1, because we're gonna check it for the next valid case. Finally, we're gonna return the result. Now let me just run it to check if it works. Oh, this is not d. I'm gonna use the c as the counter. Yeah, now as you can see, it works. Now let me just submit it. Yeah, I think the difficult part is how we're gonna use a hash table to make the problem easier, because definitely we want to find some subarray. So if this is a valid case in between, yeah, and later on we find another valid case, so we need to update the value. Yeah, so this just means if we find a number, this is a 0, and for the prefix sum up to here, this is also 0. So this means it is a valid case. Maybe from prefix sum to here, this is also a 0. So this is also a valid case. From here, this is one case, but from here, this is going to be 2, because this is 1 to 0, it's another 1. Yeah, and for here, it's going to be 3. So this is why we're going to code it like this. And the time and space complexity is going to be O(n). I think that's all about it. Thanks for watching. See you next time.